All right, hey there guys. Today we're going to look at naming polynomials by their terms and degrees. So one thing we have to understand is, what is a term? A term is like 2x. 2x is a term. If I put +1, that means there's two terms. So this would be a term and this would be a term. So then there would be two terms. And so on. And then degrees are the exponents you use. So if you have x squared, this would be a degree of 2. If you have x squared y, now this would be a degree of 3, and so on. And we'll talk a little bit more about that as we get through what we have for today. So, polynomials are named according to their degree and the number of terms. So, when we talk about degrees, this is kind of an important definition for a polynomial with one variable. The degree is the largest exponent. So for example, something with a 0 degree would be what we call a constant, which would be the number, like just a 3. And anytime you have just a number, that's always going to be a constant. A first degree would be what we call linear, and that would be like 2x plus 1. A degree of 2 would be what we call a quadratic, and that would be like x squared minus 3x. A degree of 3 would be what we call cubic. So this would be like y cubed plus y squared plus 1. A fourth degree would be what we call quartic. Very rarely used, but this would be like x to the 4th minus 3. A degree of 5 is quintic, which would be like y to the 5th minus y squared. And then anything with 6 or more is what we call, like in this case, it would be like 6th degree and so on. So it would be whatever degree it is. So then this would be like, I don't know, if it were a to the 6th plus a to the 4th, this would be 6th degree because it has an exponent of 6. So going back to the idea here that these exponents are what matter. So here there's no exponent. Here it's implied a 1. We have a 2, 3, 4, 5, 6, and so on. That's the value that's just by itself, and it's cubic because it has an exponent of 3. Call this a quartic. So that would be what we call quown. You should be in a good place here. Now let's talk about the terms. So the terms are always separated by addition or subtraction. So I already kind of gave you an example. If we have one term, let me change colors here just because I feel like that's going to be hard to see. If we have one term, this is called a monomial. So this would be like 3x. If we have two terms, the prefix is binomial, or the prefix is bi, so binomial. So this would be like 2y minus 4. If we have 3 terms, this is what we call a trinomial. So this would be like x squared minus 3x plus 2. And anything more than 4 is simply a polynomial. So you could have something as simple as y cubed plus y squared minus y plus 4. So they're I mean, and this can go on and on and on. So those are all going to be polynomials. It's kind of a generic name for them. So today we're going to be just literally naming these. So keep in mind that when we have a constant, one thing I want to talk about is a coefficient. Remember the coefficient, let's say you have 3x, this value is what we call the coefficient. Right there, okay, the number that's in front of the variable. The binomial part comes from here. It has two terms. So then we're going to try and write these two tables. So let's go ahead and name some of these. We're going to name them according to their degree in terms. So here, for this first one, we have to look at that degree, which is a third. It has an exponent of 3. So this is be what we call a cubic binomial. Help if I wrote clearly. Binomial. Let me fix that for y'all. And we know it is a cubic binomial because now when we look at 5 is what we call just a constant because it's just a number. The next one has 3 terms, so we know it's trinomial. The largest degree is polynomial. So quartic trinomial. Now 0 is a little bit tricky because 0 truly doesn't have an exponent. It really doesn't even exist. So we would say that this one would be no degree because it doesn't exist. Okay. Now, this next one is a little bit tricky as well because it has multiple variables. So what we would do here is actually add these guys because it's part of the same term. So we know this is going to be a binomial because there are 2 pieces. We add those together, so that would be a 5 to make the largest exponent. So this would be a quintic binomial. Kind of tricky, I know, but you know, this is just being able to recognize. So